Jayavadana. I am working as assistant professor in CSE department. Now I am going to discuss you about leaky bucket algorithm. So what are the topics we are going to discuss is, first you are going to see about congestion, traffic shaping algorithm. In this traffic shaping algorithm you will see two types, one is leaky bucket and another one is token bucket, and we will see one algorithm example, uses and advantages and disadvantages. So before getting into this leaky bucket algorithm directly, let me explain what is congestion. Congestion is a state occurring in the network layer when the message traffic is so heavy that it slows down the network response time. So it tells about this paragraph, it tells about the effects of congestion. That means as delay increases, performance decreases. That's what I have given in this point, where the transmitting nodes are constantly adding the packets and some nodes removing the packets from the queue. So if too many packets are present in this queue, means automatically the transmitting nodes pour the packets at a higher rate. So this automatically it will degrade the performance, and the situation is going to be called as congestion. Next you are going to see about traffic shaping. It regulates the average rate of data flow. It is a method of congestion control by providing shape to the data flow. So as I have told you before that traffic shaping algorithm, it consists of two types. One is leaky bucket algorithm and token bucket algorithm. This leaky bucket algorithm will be discussed by myself and token bucket algorithm will be discussed by another faculty. So here I have drawn two diagrams. One is two figures. This A, it takes leaky bucket with water, and then in B you are going to see about a leaky bucket with packets. So here why I have taken this leaky bucket with water in the sense, so imagine a bucket with a small hole in the bottom. So no matter at what rate water enters the bucket, the outflow is at constant rate. So when the bucket is filled with water, additional water entering means it automatically spills over the sides and this get lost. So that is what I have given in this example. So here similarly each network interface, so this is a network interface. This network interface contains a leaky bucket and the following steps are going to be involved here. So when the host wants to, this is a host computer, when this host wants to send the packet is thrown into this bucket. So now you are going to consider this bucket as a buffer. So the bucket leaks at a constant rate. That means I have given you about two things. One is here inflow and here outflow. So inflow may be considered as an unregulated flow. After you have implemented this leaky bucket algorithm, you are getting the output as a regulated flow. That is what the inflow may be a bursty traffic and the outflow may be a regulated flow with a finite rate. So here the host computer, if it wants to send the packet is thrown into this leaky bucket. The bucket, it will leaks at a constant rate, meaning that network interface transmits the packets at a constant rate. Bursted traffic is going to be converted to a uniform traffic by this leaky bucket. So here as a real-time application, we can take one best example as digital media. In this digital media, the bursted traffic, it is going to be taken as a inflow is going to be a bursted traffic, and by applying this leaky bucket algorithm we will get a uniform traffic. That means we will get a regulated flow of packets. We will see one example algorithm. There are three steps in this leaky bucket algorithm. The step 1, initialize the counter to n at every tick of the clock. In step 2, if n is greater than size of the packet in front of the queue, send the packet into the network and decrement the counter. So we are going to see one example for telling this. You are going to take this n is equal to 1000. As I have told you before, initialize the counter to n at every tick of the clock. So initially the n value is going to be taken as 1000. The packets are 200, 700, 500, 450, 400 and 200. Now you are going to take this you are going to check whether my n is greater than front of the queue. This 200 is going to be taken as the front of the queue. If it is greater than front of the queue means, so this packet is going to be sent to the network. So n is equal to this 1000 minus this 200 will get 800. So this packet diagram, it is going to be redrawn again. 200, this 700, 500, 450 and 400, and now the packet size of 200, it is being sent to the network. Again, this is my new n. My new n is 800. Now this 800 is going to be compared with this 400. This is going to be taken as the front of my queue. So n is great. Since again n is greater than front of the queue, now n is equal to this 800 minus this 400. Now the packet size of 400 is going to be sent to the network. Now the diagram is 200, 700, 500 and 450. Here we should be very careful because my new n is 400. This 400 is going to be compared with this 450. This is the front of the queue. So here n is less than front of the queue. Therefore the procedure stops. And we initialize n is equal to 1000 on another tick of the clock. We are going to see advantages of this leaky bucket algorithm. Token independent. Packets are transmitted continuously, sends the packet at the constant rate. Disadvantages, it does not save the token. If bucket is full, automatically the packet or the data will be discarded. Thank you.